So those were the three layers of interior of Earth, and now we will talk about the discontinuities. What is a discontinuity? See, when we go from one layer to another layer or one area to another area, there is always an abrupt change. Like if you are sitting on a sea beach and you go to the water in the ocean, uh, there is a change in the medium. So when you're sitting on the sea beach, you're sitting on a solid medium, it behaves differently. When you put your feet in water near the near the sea beach, then the liquid in the ocean behaves differently, your feet become wet, and you feel totally different. So there is a margin between that water of the ocean and the land where you are sitting. That margin can be called as discontinuity. So all the discontinuities behave differently because there is an abrupt change either of the medium, or the medium here is solid, liquid, or gas, or the temperature. Like sometimes you go directly from a high temperature to a low temperature area. It is like when you are entering into a room which is chilled with AC, and you're coming from outside where the temperature is high. So you feel the abrupt change. So these are called as discontinuities. There are two important discontinuities in the earth. One is Moho discontinuity and the other one is Gutenberg discontinuity. So let's discuss both of them. Homorrhoic discontinuity forms the boundary between crust and mantle. So this is thin crust and this is green belt. This is mantle. Light green and dark green is mantle. So this A, that is 35 kilometer, this is called as Moho discontinuity. Discontinuities are made with the black lines, so you can easily understand them. Moho discontinuity is between these two lines. Okay. It occurs at an average depth of 8 km beneath the oceans and 30 kilometers beneath the surfaces. You can see that it is 8 km. This discontinuity is just 8 km. Where is it found? It is found so close under the oceans. But under the continent, which is expressed through brown color, so this is a continent. Under the continent, it is 32 kilometer. You can see that there is a depth here and there is less depth here. So it is found at a deeper place under the continent. It is found close near oceans. This is called as Moho discontinuity. The cause of Moho discontinuity is thought to be change of rock composition. Obviously, we are going from a solid surface to a liquid surface. By now, you all should know that this light green layer is upper mantle and upper mantle is liquid in state. So we are going from a solid state to a liquid state. That is why Moho discontinuity is found. There is abrupt change. And we also see the change in the rocks also. So there is a rock composition which is changing. So here there is a feldspar, but there is a no feldspar in this continuity. Now second continuity is Gutenberg continuity. It is the boundary between mantle and core. Now you see this is the green shade is mantle and the yellow shade is core. Now this discontinuity, that is number B, represented with a black line, is called as Gutenberg discontinuity. Gutenberg discontinuity is found between mantle and core. Remember it. Obviously, it will be found where mantle is finishing. Mantle is finishing approximately at 2,900 kilometer. So this continuity starts from 2,800 kilometer. And as soon as mantle is over and core starts, this continuity is also over. So you can say the depth of this continuity from the surface of the earth is 2,800 kilometer. What is the name of the discontinuity? Gutenberg discontinuity. There is an abrupt change in seismic waves. Seismic waves are earthquake waves. So if at all earthquake waves travel, then since they travel in a solid air and suddenly they enter into a liquid, from solid of lower mantle to liquid of upper core, there is a change in the waves. So waves bend a bit when they come to this layer. There is an abrupt change in seismic waves. Seismic waves are earthquake waves. This continuity has a high density because of iron. We all know by now that core of the earth has iron.